This is quadratic inequalities in one variable. For our review, let's look at linear inequalities in 1 and 2 variables. So our first one here has just one variable, so it's going to fit on a number line, which is one dimension. -7 on both sides. We got 21x is greater than -7. Divide both sides by 21. We get x is greater than -1/3. Draw our number line, and the scale doesn't really matter, but 1/3, these are x values, and we want to open circle and x is greater than, so we're going to say that it's all of these values here. Next one, linear inequality in 2 variables. This is going to fit on a plane or a graph because it has 2 dimensions to it. This inequality here is the solution. Y is less than or equal to 1 minus 2x. So algebraically, there we go. But it's graphically where we can show our solution area more clearly. So we'll just draw a graph here and plot this on it. We've got a slope of -2 and a y-intercept of 1. Something like that. And we want a solid line because we're less than or equal to. And so we want this area here. All our solutions will be in this region. This is 9.2 in our textbooks, quadratic inequalities in 1 variable. This may be the hardest section in this chapter because we only have 1 variable, but we're used to quadratics having 2. So a quadratic inequality in 1 variable may be written in any of these forms here. They could be written in Vertex form or factored form as well. It doesn't matter. We can solve these inequalities graphically or algebraically. Graphically is going to be a good way if the quadratic is nice and easy to work with. In other words, if it's nice and easy to factor. Algebraically, there'll be 3 we'll go through. Roots and test points are probably the best option long term. It's nice and useful and many students like it, but we'll look at these other 2 just to show that there are more options. First method, solving graphically. We want to solve x squared minus 10x plus 16 is less than or equal to 0. So with this one, when we solve graphically, we pretend that there's a y value. And there isn't really a y value, and this doesn't really go on this Cartesian plane because you see this axis is y. But we're going to take this whole thing and say that this is our y here. Okay, so the first thing we need to do is find the x-intercepts. Determine the zeros of the quadratic function. Next, we'll want to graph the function using those x-intercepts. We don't have to graph that carefully. We're mostly concerned with the x-intercepts. Let's give it a try here. So it would be x minus 8 and x minus 2 is less than or equal to 0. So we can see that our x-intercepts are 2 and 8. We want to graph this function using those x-intercepts. So 2 and 8. Let's mark those here and here. It might be a good idea just this time for practice. Let's find the vertex. The vertex will be halfway in between. That'll be at 5. And so if x equals 5, then this is -3 and this is 3, so negative 3 times 3 is negative 9. So vertex is at 5, negative 9. We can fill in some more points. I mean, this thing doesn't have a stretch, so 1, 2, 3, just looks like a normal parabola here. Whoa. All right, so there is our parabola. And it's sort of ugly, but sorry about that. Now, the next thing we want to do is look for the solution. So we called the whole thing, this whole quadratic, we called y. And we want to know when is it less than or equal to 0. Not when x is less than or equal to 0. It's when the whole equation or our y values are less than or equal to 0. So if we look at this, where is it? Where's the graph less than or equal to 0? That would be all of this down here. All of this part of the graph, all of this part of the parabola is less than or equal to 0. Again, we're not looking at the x when x is less than or equal to 0, looking at the whole equation together. And then once we've found this part of the solution, now we need to go back and look at the x's and say, all right, what values of x make that happen? And we want to write a solution statement for that. So what values of x will make that happen? Well, in between 2 and 8 is where that happens. So all the x values in between 2 and 8. And since we are less than or equal to, we can take those x-intercepts as well. And so that's our solution statement. Any value, any x value in between 2 and 8 will make the whole parabola less than or equal to 0. Let's give it a try. Say we try 3. Okay, so try x equals 3. X squared minus 10x plus 16. X squared minus 10x plus 16 less than or equal to 0. That'll be 9 minus 30 plus 16. And that does indeed work. So negative 14 plus 9 is negative 5 is less than or equal to 0. Cha-ching. Example 2, we want to solve this one graphically as well. We've got 2x squared minus 7x minus 8 is greater than 0 this time. So we want to graph this. It doesn't look like we can factor this very easily. So maybe we could use the quadratic formula. And that would be x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So negative b would be that, negative 7, b squared, negative 7 squared minus 4ac, all over 2a. This is going to be 7 plus or minus 49 plus 64 all over 4, and 7 plus or minus root 113 over 4. Not very nice, but there we did it. Can't simplify this. 113 is good in there. We can't take anything out. So that's our two x-intercepts. Now we do need to know about what this is. So the square root of 100 is about 10. So let's just say this is just over 10. So we got 7 plus 10 is 17 divided by 4. It's about 4. So it doesn't matter where it is. This is the larger one though. This is 7 plus root 113 over 4. Let's get the other one. 7 minus 10 is negative 3 divided by 4 is negative 3/4. So the other one is some point here. That would be 7 minus 4. And then this thing opens up because it's got a positive leading coefficient. So this graph comes down here, passes through that x-intercepts, and passes through that one. And I don't really care. I don't need the vertex. I don't need anything else. I'm just wondering, where is this graph greater than 0? So if you look at this graph, this time it's the two ends. It's this side and this side that's greater than 0. So we want to look for the solution now. We want to say which x values are going to give us this leg here. So that would be x is greater than 7 plus root 113 over 4. And then this leg here, x is less than 7 minus root 113 over 4. If we have two intervals for our solution, we want two inequalities. Example 3, we want to solve this one graphically. X squared plus 1 is greater than or equal to 0. So let's graph this. X squared plus 1, there's our x squared plus 1. Okay, that's how it looks. Now, this one's pretty easy. We don't need to do anything. X squared plus 1 is always greater than or equal to 0. It's always higher. So we put any x value in here and it's going to be greater than or equal to 0. And so our solution is any real number. Will do for us just fine. Let's move on to algebraic methods, sign analysis. First up, determine the zeros of the quadratic function. I think we've seen this one already. X minus 8, x minus 2 is less than or equal to 0. Plot the zeros on a number line. All right. There's 2, there's 8. Use the factors to create a table. All right. This is going to be here, x minus 8 and x minus 2. So this is my table, kind of like this. Yeah. Analyze the regions for each zero and their product. Need one more. Product or overall. So over here in this first interval, there's 3 intervals, 1, 2, and 3. In this first interval, what's x minus 8? Positive or negative? We're just looking for the sign, positive or negative. So in this interval, it's negative. We look in the next interval, it's also negative. You could try a value if you're unsure, say 3. 3 minus 8 is negative 5, yeah, it's negative. We try something over here, 9. 9 minus 8 is 1. Ooh, this went positive. Let's try this one, x minus 2. Well, it's negative in this interval here, negative. In between 2 and 8, it's actually positive, and greater than 8, it's also positive. So now we look for the product overall. Negative times a negative, because that's what we're doing here with these factors. This factor times this factor. Negative times a negative is a positive. Negative times a positive is a negative, and positive times positive is positive. And now we're looking for where's that quadratic less than or equal to 0. Now if it's less than, we're looking for the negative. This is our solution interval in between 2 and 8. And we want to include the 2 because we're equal here, and include the 8. Method 3 is our next algebraic method, case analysis. We want to solve this one using case analysis. It's actually the same one we did before. We want to factor it. We want to think of all the cases that will result in the scenario that we want. Now we want less than. If we wanted greater than 0 or greater than or equal to 0, then we want both our factors to be positive or both negative. So when we multiply them together, they become positive overall. If we want negative, like in our case here, we want one of the factors to be positive and we want the other to be negative. So when we multiply them together, we will get the negative result that we want. Let's start off by factoring this one. X minus 2, x minus 8, less than or equal to 0. And we'll say case number 1. X minus 2, we'll say this one's positive and this one's negative. That will be our first case. When we multiply them together, we'll get a negative overall. So x minus 2 can be greater than or equal to 0, because we can be equal here. X minus 8 needs to be less than or equal to 0. That way it will be negative. We'll just rearrange these so we can see when this happens. So we'll add 2 on both sides, so we get x is greater than or equal to 2. Add 8 on both sides, this one will turn into x is less than or equal to 8. And to see where that happens, you might want to draw a number line, or you can just look at these two and figure it out. This one says greater than or equal to 2. This one says less than or equal to 8. And they both are satisfied in between, in this area right here. So we can say that if x was greater than or equal to 2 and less than or equal to 8, we would be in this case 1 and we would successfully be negative or 0 overall. So there's a solution. Let's check the other case. The other case could have been this one negative and this one positive. So let's work with the other one now. Case 2, we'll call it, where x minus 2 is less than or equal to 0 and x minus 8 is greater than or equal to 0. Do some algebra. This one is x is less than 2. This one is x is greater than 8. Now, if we put that on a number line, there's 2 and there's 8. X is less than or equal to 2. And x is greater than or equal to 8. X can't satisfy both of those at the same time. So this case is not possible. So there's no solution coming from this case. Our last algebraic method that we're going to go through is roots and test points. So let's solve this inequality. The first thing we notice is there's a 9 on this side. We want to move that over. We never want a number over here because it's more complicated to compare. We wanted 0 so that we can just see if this side is negative or positive. Now that we have this, we want to find the roots. We can do that by factoring this one, x plus 9 and x minus 1. And so our roots are -9 and 1. And just to see what these look like and work with this, we can put it on a number line, space them wherever you want, but evenly so you have some space here and here. These are each intervals, so from -infinity to -9 is an interval. And from -9 to 1 is an interval, and 1 to infinity. And this quadratic cannot change signs without creating a root. And so we know that this will all be positive or it'll all be negative. Same with this interval, same with this interval. So we want to test each of these intervals to see what's happening, whether it's negative or positive. So we want to just pick a value for x, pick a value that's easy to work with. In this case, we could go for -247, but let's just go for -10. Put -10 in our factored form here. I think it'll be easier to work with. -10 minus 1, and let's just see what we get. -10 plus 9 is -1, -11. So this turns out to be +11. So this interval is going to be positive. All right, let's test this interval. Pick a value that's easy to work with. I'd say 0. Plug 0 in here, and we get 9 times negative 1 is negative 9. So this interval is negative. And then the last interval, and we know what this is. This is a quadratic, it's coming up, it's going up here. This has got to be positive, but for completeness, we should just show what this would be. If this is an unfamiliar equation that we're working with, then we would really need to test every interval. Right, this is 11, and 2 minus 1 is just 1, so this is 11. So this is positive, just like we expected. These are all x values that I'm testing here. All right, and we wanted when is it greater than or equal to 0, or when is it positive or 0. So we'll come down here. This interval, we want this interval, not this one, because this one's negative, and we want this one. Let's write out our solution. We want x is less than or equal to negative 9. And for this one, we want x is greater than or equal to 1. And we have two intervals, and so we want two inequalities in our solution. Example 7 is the same deal. We want to use roots and test points to solve this one. First of all, let's move the 9 over there. 2x squared plus 17x minus 9 is less than 0. And we look, can we factor this? 2 times 9 is 18. Ooh, I think we can. This would be 2x. This would be an x. Then we need to figure out what goes in here. We need the 2 times 9 to give us 18. And that will give positive and negative. Okay, that means our roots here are 1/2 and negative 9. Draw out our number line so we can see where these are. Negative 9, 1/2. These are x values we're working with. Of course, they're the only values we're working with. Let's test. X is negative 10, I guess. It's the best we've got. Put negative 10 in here. Negative 20 minus 1. And negative 10 plus 9. So that's negative 21 times negative 1, positive 21. That means this interval is positive. Let's do the next one. Test. X is 0. That means plug in 0 here. We're just going to be left with a negative 1, and plug in 0 for that factor, and we're going to be left with 9. That's going to be negative 9. So this interval is negative. Just like the last question, we know this one's going to be positive because that's what parabolas do. Test. X is 1. 2 minus 1. 1 plus 9. And that gives us 1, and that gives us 10. So indeed, this is a positive interval. Now we can write our solution. We want less than 0. That means we want this interval, the one that's negative. So negative 9 less than x is less than 1/2. And that's our solution. You can see this time we have one interval. So we're going to write one inequality. Example 8 is a word problem. Maria has 40 meters of fencing to build a rectangular pen for her dog. She wants the area to be at least 36 square meters. She'd like to know what the length and width is, and she wants to use all the fencing. No side of the pen is against the wall or other barrier. They are by themselves. First, we need some variables here, so let L be the length of the pen, and Let's let W be the width. Now we've got some equations we can make. She's got 40 meters of fencing, so that would be the perimeter. So 40 is equal to 2 times the length plus 2 times the width. And we've got another equation here, or inequality, because it says at least. So we've got 36 needs to be the smallest area. The area of the pen is length times width. So 36 is the least it could be. The area can be greater than. So now we have two equations here. One of them is an inequality. Let's work with this first one because we have a common factor. So let's divide the whole thing by 2. We get 20 equals L plus W. And we want to isolate one of these variables to sub it in so we can get rid of one of the variables here. We can solve this. So let's isolate for L. Got L is equal to, what, subtract W on both sides? So 20 minus W. Now we have L, we'll sub it in here. So we'll use this equation next. 36 less than or equal to 20 minus W, subbed in there for L, and the W is still there. And now we have an inequality, and we have one variable. Looks like it's going to be a quadratic, so let's multiply this out, rearrange it. We've got 36 is less than or equal to 20W minus W squared. Let's add everything on this side. I just like working with a positive leading coefficient, so plus W squared on this side, plus W squared on this side, minus 20W on this side, minus 20W on this side. So we have W squared minus 20W plus 36 is less than or equal to 0. Now we want to factor this. We could solve this using roots and test points. Let's see, W minus 18 and W minus 2. We'll make this work. That means that our roots are W is 2 and 18. Putting that on a number line so we can test each interval here. We've got 2, we've got 18, and these are W values we're testing. We'll test a number over here. How about 1? So in our inequality here, we're going to plug in 1. And it looks like we got negative 17 and negative 1. So that becomes 17, so that's positive. Now we're looking for where is this thing less than or equal to 0, so that's not going to be the interval we want. Next one, let's test W equals 3. That would be 3 minus 18, 3 minus 2, negative 15, and 3 minus 2 is just 1, so negative 15. This interval is negative, that's the interval we want. And this one will be positive, but we'll just show that we tested it. And 19 minus 18, 19 minus 2. This is 1, this is 17. Sure enough, it's positive. So we want this interval right here. So our solution is any width in between 2 and 18, including 2 and 18. If our width is in between 2 and 18, let's just go back up and see what our length was. It's 20 minus W, so I'll just add that in there. This would be the length is 20 minus W. So whatever W happens to be, the length is 20 minus that value. Now there really was no reason why this was the width, so we could have actually done this completely backwards, just flip the length and the width around, and we'd actually get a sort of different looking result, but ultimately it means the same thing, because who's to say which is the length and which is the width? That's something that we made up. So either of those would have worked. If you did it the other way, then great.
Great job.
This is under Relations and Functions 8, solving problems that involve quadratic inequalities in one variable.
Whoopee!
There's some homework.